In this lesson, we're going to look at what's going to happen if our exponents are 0 or negative. First, for 0, so we learned the other day when we were looking at our tables that if the exponent is 0, it's always going to be 1. That is assuming that the base is not 0. So any other number, like if I have a base of 12 to the 0, will just be 1. So anything to the 0 power is going to be 1. And then for negative exponents, I first want to make a note that we learned that a negative exponent does not mean that we have a negative answer. So if we have a negative exponent, that does not tell us we're going to have a negative answer. What it did tell us is that we are going to have the reciprocal answer. So 2 to the third is 8, and 2 to the negative third is going to be the reciprocal of that, so 1 over 8. So for some examples, we can think of this as being a fraction over 1. Because we've got that negative, we're going to take the reciprocal of that. And then because it's a number I can evaluate, we'll do 3 to the third, and 3 to the third is 27. So we moved this 3 to the negative 3 down into the bottom, and when we did that, the exponent became positive. So when we take that reciprocal, it makes that exponent positive, or the opposite. So same thing here, this is over 1. This has a negative exponent, so we need to flip it. So this first value here is in the numerator. It needs to move down to the denominator, and when we do that, it becomes positive. And then we're going to have a 1 as a placeholder on the top. And then because that's a numerical value, we can evaluate it. 2 to the fifth means I'm multiplying 2 by itself 5 times 2 times 2 times 2 times 2 times 2. And that's going to give us 32. In number 3, anything to the 0 power is going to be 1. So we're going to combine those two things here in number 4. First, we can look at 8 to the 0. Well, that's just 1 times, and then we can worry about this 2 to the negative 3. Well, think of it as a fraction, and then take the reciprocal, so 1 over 2 to the positive 3, which is 1 over 8. So this first part here was 1, being multiplied by 1/8, and 1 times 1/8 is just 1/8. Number 5. Before we use our exponent rules, we can also combine these. We learned before that if we're multiplying with the same base, we can use a shortcut of adding the exponents. So 5 plus negative 4, that would be 3 to the positive 1. And 3 to the positive 1 is just 3. So in some cases, if we simplify, we actually get rid of the negative exponent. That's not the only way we could have solved. If you had looked at the negative exponent first and taken the reciprocal of this, we would have ended up with 3 to the fifth over 3 to the fourth when this 3 to the negative 4 moved down. And then we could have used our division rule where we subtract the exponent, and I still would have gotten 3 to the first. And number 6, I'm going to go ahead and use that multiplication shortcut again. We're multiplying with the same base. We add the exponents. Negative 7 plus 9 is 2, so it becomes 5 to the second, and 5 to the second is just 25. Again, not the only way to solve, just one way to solve. Number 7, when we have an exponent on the outside of parentheses, that was called power of a power, and that's when we multiplied those exponents. So the base stays the same, and then negative 2 times 3 is negative 6. Now I end up with a negative exponent again, so we're going to think of that as a fraction and take the reciprocal of it, 1 over 2 to the positive 6. And then 2 to the positive 6 is 64 when we multiply all those 2's out. Similar on number 8, we're going to multiply those exponents, so that's 6 to the negative 2. Can't leave that as a negative exponent, so take the reciprocal of it, 1 over. When I do that, I get a positive exponent. And 6 to the positive 2 is 36. Number 9, again, we're going to multiply the exponents. Negative 1 times 3 is negative 3. Anytime we have that negative, we can't leave it as a negative, so think of it as a fraction. Negative exponent means to take the reciprocal, so that's 1 over 2 to the 3. And when I take that reciprocal, notice that I went from a negative to a positive exponent. That's why we do that reciprocal. That's how we're going to make it positive. And when I evaluate, 2 to the 3 is 8. And it works the same way if we have variables. So on number 10, I want to make it a fraction. And then this has a negative. It's in the numerator, so it needs to move down to the denominator. So in the denominator, I'm going to have x. When I do that move, it makes it positive, so x to the 8th, and then have that 1 for placeholder on top. Number 11, there's actually a hidden exponent. That 3 really has an exponent of 1. So that negative 5 exponent only goes with the x. The 3 has its own exponent. So I'm going to think of this whole thing as a fraction. I only need to take the reciprocal of what has a negative exponent. So the only thing that has a negative exponent is the x. So this x has to move down to the denominator to become positive 5. But the 3 already has a positive exponent, so the 3 can stay right where it's at. Similar on number 12, the only thing that has a negative exponent is this x to the negative 2. So that needs to move up to the top. Well, the 7's already in the numerator. Now I'm moving the x to the second to the top to make it positive. So I have nothing left in the denominator. I could put over 1, but when we divide by 1, that doesn't really change anything, so we can just leave it as 7x squared. Same thing for number 13. The only thing with a negative exponent is the x down here, so it has to move up to the top. The 9's already in the top. It can stay where it's at because it has a positive exponent. It has a hidden 1. The x has to move up to the top to become positive. And again, there's nothing left in the denominator now, so I could say that there's a 1 left. Or dividing by 1 doesn't change anything, so we could just get rid of that denominator in that case. Number 14, now we have 3 pieces. We have an 8, an x, and a y. The 8 has that hidden 1, if that helps to write it. There's 2 pieces with negative exponents, x and y. So the x and y have to move. So the x has to go down to the denominator, and the y has to go down to the denominator to make those positive. So those have moved down to the denominator. The 8 is okay to stay in the numerator where it was because it already had a positive exponent. And we don't want to move something with a positive exponent because if we did, we would actually be turning it into a negative, and we're trying to avoid negatives. Number 15, very similar to what we did in number 11. So we've got a 3 and an a to the negative 3. So just the a has that negative 3. So that's a piece that has to move, and that has to go down. So that a to the 3's got to go down to make it positive 3. This 3 out front here is already positive, so it can just stay where it's at. Even if this 3 had been negative 3, that's still okay to leave. It's only negative exponents that we need to move, not negative bases. Number 16, this y has a negative exponent, and it's already down, so then we're going to have to move this back up. So you're always going to move it to the different position and flip it. So there's nothing left in the denominator, or we can say there's a 1. The 3 can stay where it's at. The x can stay where it's at. The y now moved up to become positive. And then I can simplify a little more. First of all, I don't need to divide by 1, so I can just get rid of that dividing by 1. But also we talked about anything to the 0 power is just 1. So this really says 3 times 1 times y to the 3rd. And 3 times 1 is just 3, so 3 y to the 3rd. Number 17, we really have a hidden 1 on the 4 and a hidden 1 on the x. Now this is just one way to solve. There's always other ways. And then when the number's on the outside of parentheses, that's when we multiply. So we're going to take negative 2 times 1 and negative 2 times 1. So that becomes 4 to the negative 2 and x to the negative 2. Think of it as a fraction. These both have negative exponents, so they both need to move down to the denominator to become positive. And then because there's nothing left on top, we'll have that 1 for a placeholder. And on our last one, this whole thing here, 5 to the x, is all raised to the 0. And anything to the 0 power is really just 1. So this whole thing here becomes just 1. And then I have y to the negative 2. I can't leave that negative, so I have to move this down to the denominator. So think of it as a fraction. That y has to move down. So in my fraction, that y is going to move down to become positive 2. And my numerator stays 1. So the number one mistake that I see is if we have a variable with an exponent, we sometimes want to separate the x and the negative 2 and make it maybe like x stays and the negative 2 moves. But we can't do that. This is one piece of information. It cannot be separated and turned into two different numbers. This is one single number. So we can't do this. Wherever this x goes, this 2 is going to go with it. Depending where we put it, the 2 might turn to positive 2, but that 2 still got to stay with the x. We can't separate an exponent from its base.